If you flew in a straight line forever, would you eventually hit a wall, a final frontier where everything just stops? It's a question that's fascinated humanity for centuries. Where does the universe end? And maybe more importantly, does it even have an end at all? When you look up at the night sky, you're not seeing the present. You're looking into the past. Every pinpoint of light is ancient history, a message from stars and galaxies that traveled for billions of years to reach your eyes. The most distant light we've ever detected comes from over 13 billion years ago. Beyond that, the universe seems to fade away, not because there's nothing there, but because light from those regions hasn't had enough time to reach us yet. This boundary is what we call the observable universe. It's a massive sphere, about 93 billion light-years across, with you right at the center. And what's wild is that from any point in the cosmos, the view is the same. But here's the part that really bends your mind. The universe doesn't have an edge in the way you might think. Space doesn't just stop. Instead, it seems to bend and stretch. You could fly forward forever and never hit a wall or find a border. So if there's no edge, what's really out there beyond what we can see? To figure out where the universe ends, we have to understand what we can actually see. When astronomers point their telescopes into deep space, they're looking back in time. Light travels incredibly fast, but space is just so vast. Seeing something a billion light-years away means we're seeing it as it was a billion years ago. But here's a paradox. The universe is about 13.8 billion years old. Yet the edge of our observable universe is about 46 billion light-years away in every direction. How is that possible? It's because the universe has been expanding since the Big Bang. While that ancient light was traveling towards us, the very fabric of space between us and its source was stretching, carrying galaxies away from each other. In fact, some regions of space are receding from us faster than the speed of light. This isn't breaking physics. It's space itself that's expanding. This creates an invisible boundary called the cosmic horizon, the ultimate limit of what we can ever hope to see. Beyond it, countless galaxies exist, but their light will never reach us. They are lost to us forever, hidden behind an ever-growing curtain of cosmic expansion. NASA's James Webb Space Telescope has pushed our vision closer to this horizon than ever before, spotting galaxies that formed just 300 million years after the Big Bang. They appear as faint, reddish smudges, their light stretched and warped by cosmic expansion. But even the Webb can't see past a certain point, a faint uniform glow called the cosmic microwave background. This is the oldest light in the universe, a baby picture taken just 380,000 years after it all began. Before that, the universe was a hot, dense plasma, and light couldn't travel freely. That's where our vision stops, not because there's nothing there, but because the laws of physics prevent us from seeing it. So if we can't see past the cosmic horizon, what's actually out there? This is where things get truly mind-bending. The most widely accepted idea is that the universe is infinite. What we see through our telescopes is just a tiny, insignificant patch of a cosmic fabric that stretches on forever, with no center and no edge. But infinity has some strange implications. If the universe is infinite, then everything that can happen must happen somewhere, and an infinite number of times. That means there could be other regions of space identical to our own, with another Earth, another solar system, and even another you, repeating endlessly across the cosmos. Another theory is that the universe might not be infinite, but unbounded, like the surface of a sphere. If you could travel far enough in one direction, you'd eventually loop back to where you started. Our universe would be finite but have no border, a self-contained bubble of space-time. And then there's the multiverse hypothesis. Our universe could be just one bubble among countless others, each with its own unique laws of physics. In this scenario, our observable universe is just one drop in an endless cosmic ocean. All of this, infinite space, a curved cosmos, or multiple universes, could exist just beyond what we can ever see, hidden from us forever. To test these ideas, scientists needed to measure the geometry of space itself. Einstein's theory of general relativity predicted that mass and energy curve space-time. So, by measuring that curvature on a cosmic scale, we could learn the true shape of the universe. The best clues came from that afterglow of the Big Bang, the cosmic microwave background. When satellites mapped this radiation in incredible detail, they found something astonishing. On the largest scales, the universe is almost perfectly flat. This means parallel lines stay parallel, and light travels in straight paths across the cosmos. This flatness strongly suggests that the universe is infinite, or at least so mind-bogglingly vast that any curvature is undetectable. But here's the twist. A mysterious force called dark energy is causing the universe to expand at an accelerating rate. The farther away a galaxy is, the faster it flees from us. Over cosmic timescales, this acceleration will pull even nearby galaxies beyond our cosmic horizon, leaving our local group of galaxies isolated in an ocean of darkness. The universe might be infinite, but our view of it will keep shrinking. Right now, our night sky is filled with galaxies, each one an island of billions of stars. But this view is temporary. Because of dark energy, the expansion of the universe is speeding up. Over billions of years, galaxies outside our local cluster will drift so far away that their light will never reach us again. They won't vanish or explode. They will simply cross a point of no return. To any future observer, it will be as if they were erased from existence. Astronomers predict that in about 100 billion years, every single galaxy outside our own cluster will have disappeared from view. The night sky will be dark and empty. Future civilizations might look out into that void and conclude that our galaxy is all there is. They would have no evidence that billions of other galaxies ever existed. And that's the beautiful, haunting reality. The more the universe expands, the less it reveals about itself. Even light, the fastest thing there is, will eventually lose the race against expanding space. The clues to our cosmic origins will fade away. But right now, we are alive in a golden age of cosmology, a brief window in time when the universe is still telling its story. We can still see the distant galaxies, the afterglow of the Big Bang, and the faint traces of where it all began. So perhaps the real edge of the universe isn't a physical wall, but the limit of what we can ever know. Beyond it lies everything we'll never see, a cosmos of lost light and hidden wonders. Thank you so much for watching. If you found this as fascinating as I do, don't forget to like this video and subscribe for more journeys into the cosmos. See you next time.